Hey again, this is Doug. In this screencast I'm going to show you some tips and tricks for how to manipulate data in large data frames. We'll be using 2014 climate data from Columbus, Ohio that's archived by the National Weather Service. The data is stored in monthly files, and I've already gone ahead and gotten information for January all the way through December 2014. I've already put it into a CSV file and uploaded it into R, and you can see that file right here. You'll also notice I've started to write some parts of my script, so I've set the working directory up here. I've got a command which is new to you. I'm on line 2. This clears the workspace, make sure that there's nothing stored in memory that might get in the way later. And then this is a familiar command where I'm reading in that climate data. So let's go ahead and run what we've got so far and see what happens. Not much actually. We've run through all 3 lines of the code. We end up with this variable called climb.data. It has 365 observations and 19 variables. To see what's in this variable, you can simply click on it and you get, as we've seen before, a very Excel-like looking display. Another way to look at what's in a variable is actually just to type the name down in the console. So here I'm going to type in climb.data. Now, if I hit return, I'm going to see exactly what's in there in the console. And since this is quite an extensive data frame, you can see that there's a lot of information. If I go all the way to the top, you'll also see that the headers for each of the column are also displayed. And again, if you're looking for what some of this information means, I encourage you to go back and look at the website that I referenced earlier in the screencast for an explanation from all these symbols. Okay, so now that you got the data, let's go ahead and plot something. And let's go ahead and plot the day on the x-axis and the average temperature on the y-axis. So to do that, let's just do it in the console. Come all the way to the bottom. We know that it's going to be plot the name of the data frame, which is here going to be climb. Now, you'll notice that I typed really quick. What I did is I hit tab and R will autocomplete. Saves a lot of time if you've got a lot of complicated names for elements in your program. Now we put $. Again, the x-axis we want it to be day, and then y-axis again climb $, and I think it was AVG was average. Hit return, and we get something that looks like this. It doesn't seem to make a lot of sense. We're expecting a plot that should have, as you can see right here, 365 days in the year, but on the x-axis here you can only see that there's 31 observations. The y-axis looks reasonable. This must be temperature in Fahrenheit because it, of course, goes all the way to 80. Now the fact that there's only 31 observations, which is the number of days in the month, suggests that there's something wrong with this variable here, the dy variable. So if you look at that, going back into the data frame, it's just scrolling down. It looks right in January, and there's 31, and it starts at 1 again. So our problem is that these aren't Julian days, which is the number of days in a year from 1 all the way to 365. These are days of the month. So a way to get around this is to actually add another column to our data frame. So it might appear over here. And we're going to do that up here in the scripting window. So what I'm going to do is I'm going to create a variable, and I'm going to call it jdate or j.date. And it's going to be a sequence of numbers from 1 to 365. So again, if I go ahead and execute that, you'll see here again I've got now another variable that's 365 values long. But I still have 19 variables in climb data, so that didn't seem to work yet. Now the way around this, I'm going to use a really useful command, one that I think you'll find taking note of is important. It's called a cbind command. So what I'm going to do is I'm going to say my new climb.data, so the new data frame is going to equal, or at least I'm going to assign to it, the results of this command, cbind, which stands for column bind. I'm going to put the old data frame in it, and I'm going to add to that j.date. Okay, so if I do this, my expectation is that after running this command, that the number of variables over here will increase to 20. So let's go ahead and give it a try. And there we go, it's to 20. If I want to see what's in climb data, I'm going to come back down to the console, hit climb.data, and look at it. And what you'll notice now is that there's a new variable inside the data frame called j.date. So if I wanted to make a plot that had each day of the year, I'm going to say something like plot climb data $jdate, and then climb.data $average, AVG. If I run this script, there's my new plot. And this makes much more sense. Now we've got the first day of the year here at 1, the last day of the year at 365. Looks like a nice sinusoid, which is what we'd expect for a round planet that's tilted and goes around the sun. One of the things that would be nice, however, is to actually connect all of these dots with a line so it became a little bit more clear which day came after which. To do that, I'm going to add a little bit of code to my plot command here, and it's going to be something called type, T-Y-P-E, equals quote, and here I'm going to use O. If I run this again, you'll see now I have lines there that connect my data points. If I wanted to change these dots to some different symbol, I could use this command pch equals, I'm just going to put a number in here. Now it looks like 1 was the default, so let's try 2. Now I have triangles. 3 is plus symbols, and this goes on. You can look up all the values that exist for PCH. One that I think is pretty nice is 20. You get nice small dots.